How about friends? How are they? Welcome to this new coffee and crypto video. On this occasion, we are again with Andres Leon, which we can practically say from home. We are not in this series making videos to learn script, to learn to program script from scratch from the beginning. This is episode number 4. We already have 3 more, this one that we are doing where you can go. Seeing then moving forward on this journey to learn to program in blockchain. So this is learning blockchain in Radix for beginners. This one from scratch from the beginning. What about the episode today's episode. This one is titled First Steps with Script. In the previous ones, we first saw an overview of what Radix has been like. Our transactions handled in Radix. Then we installed some instances, some tools that we need to be able to access, start programming last week. We reviewed a little about the front end and the back end, as well as making that connection and that. Let's interact, and today we are going to begin to review these first steps in what has been described, which is the programming language used for radios. How are you, Andres? Welcome to this video.
How are you, William? Well, I'm glad to be here for another week. Today we are going to leave a little so much theory. It's worth less, and we're going to focus more on the code, which is what interests us all, right? Although I would like to at first. A little bit of a theory board is very simple. This time you'll see, okay, I'll share the screen.
Of course, I take this off, this mask, and we put it here.
Right from 0 to 100, okay? Over the past weeks, we have seen that in Radix script, in reality, we create something known as components. These, we are going to basically create something called, that is what we execute. What traditionally any type of other DLT, smart contracts, in Radix we know as components. Not what we would say in Spanish components. Okay, they are components. Okay, this would be our smart contract. Why do we call it a component? Because different other networks. This proceeds from this component is nothing more than the instance of a blueprint, okay, or a template, little we could say about a plan, not a plan, better said, no, this is blueprint, okay, let's put it here. Let's create it, blueprint, this is blueprint, okay, it's what we really write. Okay, this is where all our code is. And from this blueprint, when we instantiate it, okay, it is when we say we generate a component with which we can understand that once we have created a blueprint, we can instantiate this blueprint and it can create as many components as we want. This is as if in another language, in another type of language, we talked about structures, about speaking, about classes. Okay, the concept is very similar. In actually, if we remember in the second class, we used a command that was script, okay, the tools. We remember that we installed the programming tools. One tool was script and the other was resi. And we have written new package, okay, and then the name of what we wanted to call that package. What is this package? Well, the package is nothing more than another upper container. Is all this worth it? This has to do with Rust, how Rust is structured, okay? But if there is a top-level package, this would be a package. A package is okay. It is more than a container is okay, where now we can write at least one blueprint, okay? But that the packages, it allows us to build within them or create different blueprints, okay? And once we've created these different blueprints, okay, then we could instantiate. Or one or all packages are worth in one or more components. In the end, within the network is worth address. The packet has a val address, and the component has its address. The difference, although the component also has the code obviously makes the difference. The thing is that the component, as it has life, let's say, has life within the network, it is not simply a code stored there. Okay? Well, then we are going to be able to save data within this component. That is, we can have a state or even assets worth data and assets, and we can save this within the value component. And then it has all the logic that we have already written here, valid within the blueprint. And that's the main difference. When I instantiate a blueprint that is inside a package, what I do is I finally allow it to save data or assets inside. I mean, let's say it already has a life of its own. We could do the example with a house, okay? I think we've already done it again, right, Guillermo? The example of the house, an architect created a plan, and now from that plan, you can create a house where people can live. Obviously, you can see the plan and you can see how everything is designed and what the measurements are going to be, etc., etc. But until someone urges it, they don't create it. They don't give life to that plane, because then people can't go inside to live. And just as an architect can make a plan for a single house, an architect can make a plan to, with a single plan, be able to create 1111, an entire neighborhood full of exactly the same chalets, because this, in this case, occurs. Seen, this was not invented by Radix, okay? This is basic of especially of object-oriented programming languages. And let's remember, written, it is not object-oriented, it is asset-oriented. Hence, it is interesting that it not only collects, or in reality comes to turn it into an active object of some kind. Could we emulate him like this? Okay? And that's why he joins. I mean, let's say it maintains all these kinds of programming methodologies that, since we already know, okay, this is just a clarification, okay, but we move on to write, okay, to write code. Let's go to a go-to. Or make a video test that someone else can notice, okay? Come on. We're going to try to do the same thing we did last time, but slower, okay, on the second day after installing the tools, if you remember. Shall we instantiate? That is, create a package, look inside the code. And what did it look like? We're going to do the same thing, but slower to assimilate some concepts. All right. That time, we did it to prove that the development tools we installed were correct. We installed scripts. If we go slower, we will see that we are in the correct section. Is it visible? It looks good on screen A.
See if I can see like this. Does it look better?
Okay, and I don't know if I do that. Okay, it looks better this way, right? Okay, and written in its version 1.3, we are now. And then we also install Resim, which is the rates engine simulator in its version 1.3. Okay, we're both still worth writing in reality. What if we do script -h? Well, we will be able to see different commands in the resign. It is valid here that the one we are going to use a lot is that of the new package. It is valid to create a new package. We have seen it before, okay? And then the one we use in an overlapping way is that of the build, but it is used by resign in form when we do a publish. In reality, what it is doing is 111 build behind it is also valid. Well, so the first thing we saw the other day that we had to do when we wanted to start programming is, and we have seen it before, script new package. And the name, for example, we are going to say hello. And now, if we do, we enter the folder. If we do a dir, we see ourselves creating a folder. Hello. C of hello, is this worth it? C of hello, LSLS. Hello, depending on where we are, okay? You know that in each operating system, it is different, okay? And here, if we sync again, you will see that we have several folders, okay? And several files. If we go to the Visual Studio, We will see here SB. Let's see. Doing them this way is better, right? Yes. We will see that we have the SRG folder on one side, which is where we have the first package. Okay? Here we could have more than one package worth the first blueprint and possibly more, or even different blueprints in the same file. Copying this here, okay? If I copy this and put it here, okay? Now I would have to change the name and all that, because if I didn't, it would give me an error. No, but if I say it's 2.0, 2 is fine. I would take this 2 and I would have 2 blueprints within the same package. Or this could then, let's say, take it out to a file, to a different file, okay? This is just so you can see that we can have more than one blueprint. Within the same package, normally in the same package, we are going to save blueprints, voucher or code that has to do with one other voucher, that they have something that I know is worth. Imagine, well, from the same application, well, it could be perfectly, and which does not mean that we will see it much later. We can have access from a blueprint like this to other blueprints or other components, even if they are outside, let's say, of the package itself. Well, as you have seen, they are created by a basic structure of any type of module with Rust is SRC, where we will have the live file, RS. We don't have to change his name or anything. For now, it has to stay that way. Point RS, because it's from Rust. And this is where we will have our code, and then we will also have a folder with tests, where the same thing will be. But the code to do the tests are worth unit tests, okay? And then here, we will see that in reality, what it has done for us has been to load that is the configuration file of this package. And what it has done for us has been to load the dependencies we need. For example, here, valid script and test script. And that's it, huh? I don't know if it charges us anything else. Not everything else it's standard, okay? Very simple. It's a very simple charge, and that's it. Not many more stories need to be explained here. Okay, now, once we start here, what we're doing. So if you want to go, keep following me, is a little bit of following. We go to documents. Whenever we are going to start, we have the documentation next to us. It's very important. It's worth documentation here in build, here in learning. Okay. This street by step is what we are doing now. It's worth a little bit. It's what we are going to follow, not any of these examples that you put here. So today I'm going to mix it up, but if you pick it up later and want to read it. Okay? More or less, what I'm going to do today, are the first 223. Okay? We're going to try to summarize those first 2-3. Well, then what do we find here? I don't know if we're going to cover this up a little. Okay? What are we in here? Well, on the one hand, we find, well, this here, from this first line here. It is something that we may or may not understand. In the end, what is to us is preparing the programming environment for us. It is valid so that we can use script. It is a way that this Rust has to include dependency. Is it okay to tell him, look, from now on, you're going to forgive me, you're going to use script, okay? And then what we have. But not this. This always comes to us, and we don't have to change it or anything, not even understand it. It may be that in some cases we use more than us, okay? But for now, in principle, we are not going to use anything more than what we have here, like this here. What it allows is to put things like this that are in a kind of macros that the Radix people have created, okay? So that somehow then, well, then when they compile this code, they can know what they can see, what the code is, and compile everything with these macros, right? So we see that this is a blueprint, and that inside it has a module of this. We have it, that this stays here, and we don't have to change absolutely anything, anything that we can change. Well, we're actually going to do this. This is the default name of the module, and yes, we can change the module. We can give it whatever name we want. Okay, this is one thing that is completely optional. Here it says, for example, we can give it, I don't know, an example. If you realize something that is going to be told to you, okay, right now I haven't missed any type of error, but there are a series of conventions within Rust that make the code more readable. Conventions mean ways of doing certain things. For example, the modules are written with everything in lowercase. Okay, so before I had given an example of uppercase, with the first letter of uppercase, we are going to put it in lowercase. Example, like this is better. This way, it certainly doesn't give me any type of error. Okay. On the other hand, those same conventions say that structures, implementations, etc., etc. We can write all this in uppercase. The first one in capital camel is worth it, which is that I think it says, okay, so imagine if we put this, we can put it. Now, if example is okay, we would change this one here, okay, which is the name of the structure. We would change because it has to be the same, the name of the implementation. And finally, if we realize here within this that we're going to see now, it also has ice. Okay, because in the end, what we're implementing in here is a kind of what kind. The type of structure is valid, with which we would also give an example of this very simple way of in principle. Okay, we would change the name of our blueprint is valid for the module and the blueprint. The module thing is in case we want to have more than one different blueprint in here, okay, then we could have more than one module, and then from there, we have to differentiate it. In reality, the name that matters to us is that of the structure and implementation. That's the name that should matter most to us. As we explained last time, Rust has complex types such as structures. It is nothing more than a data type. Those who know programming, do you know that data types? So they are the numbers, the text strings, and Rust also has, for example, structures. So in this case, when we are creating a smart contract, the RAID people have used this methodology, module, structure, implementation, so that we believe that it is, as we say, the outline of how it has to be a smart contract, okay? And is using a structure. And if you realize, a structure is nothing more than a set of data within it, or fields, and each field in turn can also have a different data type. So it's a collection of field data types that can have completely different data types, which allows us that here, for example, in this structure, we could have, for example, a name, okay? It could be a string, it could be a name, we could have a last name that could be a string age, which, for example, could be a 3232-bit signet. We will see that. Now, a 32-bit signet is worth it because it could be with a 32-bit integer, which means that it could have a sign, okay? In this case, it is an unsigning, because a unit can never be negative, okay? So, if we realize in the end the structure is nothing more than a collection of different data that in turn may have each 1111, they may belong to a completely different type of data. Here you are already realizing that Rust, if it has anything, is that it is a typed language. Furthermore, it is said that it is a strongly typed language, that is. There are other types of language, for example, JavaScript, which is that it doesn't really have any type of typing. That's why they invented TypeScript, which TypeScript does have the same type as JavaScript. But with types in JavaScript, you declare a variable, and it can be whatever you want, and then it can first be a number, and then tell it that same variable, you modify it, and that it is a text string, and 2, and 2, and 2, and 2, and 2. The JavaScript interpreter doesn't care at all. On the other hand, in Rust, not in Rust, as in strongly equipped languages, when you declare a variable with a data type, changing it is, let's say, impossible. Nothing impossible in this world, but it is really impossible to do it. Okay? So every time we declare variables, I'll try and see that other kind of things too. We'll always try to put him, even though he can infer Rust. You can, the Rust interpreter can, and the Rust compiler can infer, that is, presume what kind of data you want to store there. But it's always good for us to tell you what kind of data we're talking about. Here you will realize, if you know anything about Rust, you will realize that we are using an unknown type. I mean, for people who already know Rust, which is Vault, this is a type of data that he has created, and that is why we bring it here, that he has created rallies. Okay? Within the script, this type of data is a container type data. That is, within this variable, I can save things. What can I keep? Well, like this, I'll be imagining. Can I store assets inside this one? On NFT1 token, 100,000 trillion tokens, all within this bowl, saying that I can only save one type of asset can be expendable, it can be non-expendable, and within, for example, of the expendables, one, I could save asset A, and asset B could only save one asset A, for example, is then valid. In the end, it is a type of data that has created former Radix process within described, so that we return to what we have seen before, so that we can manage the assets in a simple way. Okay? In this case, as simple as a container. One in this case is not a container. It is one if it is a vault type container, because we keep it permanently. Well, the assets that we want to save here, that's why we saw before. I don't know if I have already removed it, that I have removed it. I have removed it, but we saw that within the components, we can save data. We have seen it here, data or assets. And we are always going to store the assets inside some type of vault. Let's see what more vaults there are. LA, none, how is none. Let's see, there is no non-fungible. What's fungible like? This is non-fungible bound veil. These are more specialized vaults. For example, this is a specialized vault for storing non-expendable type data. The difference with the bout, which could be generic. Well, then they have different associated characteristics to be able to make more specific functionalities. For example, Lavao has a series of characteristics, and if it is non-expendable, bowl or fungible bowl, since it will have one or the other adapted, for example, to that specific asset. We'll see that much later. So if you realize this is where I'm going to keep the state, component state. This component, for example, might not have the state. I could charge a component without any type of state because I do not want to save any type of data in that component simply for it to execute a point logic, but without state. In this case, I am going to continue. That is, save the state a specific state. Okay, in this case, in this example, it is only saving sample bolt. Okay, this name is arbitrary. It could, for example, we can put sample bolt, or we can simply put volt. Okay, volt, and we should change this here, volt. Sorry. Yes, well. Once we know that we can save data or assets here, then create the implementation. In implementation, it is where the logic of our component is going to go. We are going to separate the logic into two parts. A logic to instantiate the component, and a logic to be able to create specific functions for that component. That is, a logic for the instantiated. And another logic to create functions. For that component, this is really valid. If we were very specific, we would say that these are the functions valid within an implementation, and these would be the methods of the implementation. That being very specific in the specific language. Why do you have to instantiate it? Why do we have to create a logic for instantiation and not simply instantiate? That is, take the methods and launch them. And that's it. Well, because when I create a component, I want, for example, to pass it certain parameters. Or I want certain characteristics to be created, and also that I could create as many instances as within the same blueprint, you could create as many instances as I wanted and call each instance when I wanted to create a startup behavior for that component in one way or another. So, well, that's why we believe about the instances. This is very much if we equate it to when, for example, we create a class and now we instantiate that class because we do the point, the new always, not for us. Now let's say create that class again, even if you then have certain methods, the form that we have predefined. Let's say in that interface, create that new class, because it is what here we will come to configure within this instance. That is, we are giving it the instructions for how we want that blueprint to behave when it is instantiated in this case. In this case, what this instance is doing. This is also a completely inventory name. It is called an instance. Is that you cannot put it new. For example, that is arbitrary. This instance, which we do know makes good, here we are always going to clarify, as well as public and function fns. This instance is worth what we know it does is that it returns something in Rust. The functions, when we want a function to return something, we have to say that it will return. And in this case, and it is expressed in this, or the syntax is that, with a hyphen and a kind of arrow, okay? And the major veil is kind of an arrow, and we say we want him to give something back. In this case, what we are telling him, what he is telling us here, is that we want him to give us back a global type, okay? Here, what is normally defined are type always data types. A global type, and that this also contains an example. Okay, this type contains an example, and this is going to return it to us. Well, what it is going to do is return us as its name indicates. We are going to say it like this. Okay, this is this. What I am going to say is very stupid, but so that we can all understand each other, it is going to return the address of the component to which it is going to distance itself. Okay, I know that what I am going to say has 1,000 nuances, but so that we understand it first, everyone is okay. It will return us the address where it was finally instantiated. What does this do? Well, what is this instantiation doing here? Well, let's see that what it is going to do is create a resource. Okay, we are going to look at it now in detail. Okay, it is going to create a resource once that resource. What it does is it's going to store it inside the vault. Inside this vault, this resource is going to keep it inside here. Okay, it's going to keep it inside here. Now we see how it does. And finally, okay, this comes here later because it's an okay point. What we do is we instantiate, okay, we prepare to globalize. When we say we are ready to globalize, and globalize means that prepare the entire component to be able to transfer it and execute it correctly within the virtual machine, in this case, within the Radix engine. Okay, and among other things, well, today I said it was very rude because it has to do with other things, also with permits and with another series of things that we are going to put here. What he does is he gives us an address back, if you all realize it. And that's from Rust 2. Another small tip, all the lines are valid. They are finished. They are valid with a period and a comma, not this one, because this is a way of writing. This could be done like this directly. It is valid one, followed by another. The last of these nested functions, the last one is the one with the point and comma. And this one here, if you realize, this one here ends without. Why? Because in Rust. In other places here, it can be done. Can you also do a retool? And what you want to return in other languages of the population is is it very common to use the word retail return? No. In Rustros, it can be used, it exists, but we don't usually use it because what we do is certainly the line that we want to return. It is the one that we don't put on it. That's the last line, and that's the one that returns something. And that's what happens here, when it ends. If everything is prepared and globalized, what returns to us is a type of global data that is what, among other things, returns to us. Finally, as users, is the address valid? We are going to go little by little with this resource thing. In the end, if you realize what we are going to do within a contract, within a component, is save data and assets worth and somehow create a certain logic to be able to manage those data and assets that we have saved, or others that reach us and interact with them. Okay? And one, some logic. Another thing we can do is within a contract, create new resources like this. Is it the case? Resources that then, for example, we want to save here, as we could have decided not to save it here and directly have it back to us, okay? To do this, Radix has created this function called resource builder. And here we are going to tell you that we want to create this colon, and we will see all this in more detail. No, so don't worry, resource builder is fine, and we want to create a new consumable. Okay, and here it says this, we will see now the owner role, okay? Basically what he is saying is that we are not going to assign any owner to him. Role, the owner role is the owner, or the person who would own this resource that we are creating here. In this case, we are telling you that no one is going to be the owner. No, it won't have an owner. If we assigned it, we could assign it an owner based on a logic. The logic we did could be various tokens or a non-fungible. We will do logic much later in other lessons, but we can apply any logic we want to it. Okay, in principle, the most normal thing is that an owner is assigned with 1.1 keys, a touch that will make a batch key that we say in batch Radix, okay? Or that it was the component itself. Outside the owner is also possible. Okay, that's also possible. So we're basically telling you here that you create a no 111 type of non-expendable resource and that it's not going to have an owner. Furthermore, then we are adding that it is going to have maximum divisibility. I think it is 18 zeros. It seems to me, if I remember correctly, 18 zeros that this DLT has. We tell you that here we can have said that it did not have divisibility. For example, when we see, I don't know if disability tells me here. No, it doesn't tell me. It doesn't give me the option. But come on, here we could have said that it didn't have to be divisible, or we could have adjusted the number of visible. For example, I think we can have directly told him, for example, that he had only 6. That is.
There are bad ones. For example, non-expendables have no divisibility, not that it is one NFT.
Of course, the non-fungible is this. This would not exist. Okay, no, we would not use it. The metadata would not exist. We are going to tell him that we are going to graduate a series of metadata. This is exactly always the same. No, don't think, because, well, WhatsApp is set like this. This is the same, always the same. He treats me, this gadget treats me down, admiration, so what interests us is what it is. We are going to be able to tell him that it is type key value. the name, that is the name of the metadata is valid, and the the value of the key metadata value is valid as many metadata as we want. The locket thing is because let's say we're telling him that this metadata is blocked, it cannot be changed in any way. Okay, if we didn't put anything in it, then it could be modified, for example, by the owner, for example. Okay, and here we are telling you that this is not this expendable. We are going to have an initial supply. We are going to initially mint 1,000. And the thing about the into this thing is so that he can do it, so that he can finally do it. We'll see about this later. This into is worth it. So finally, let's make a nil supply. So when this is run from here, actually what it's giving us back, if you notice here, I don't know if they give me double on top of that, he tells me. It's just that it's not for me. Wait 1 second, because it's not for me and it's not for me. It's not taking my extensions because I usually have them. Wait a minute. I have them. How strange it's not taking my extensions. Because I don't have them, I trick them. I only enable the extensions for a specific work area. I don't always have them all enabled. So if I'm working with Rust in that workspace, do I enable the extension at that time for that workspace? Well, if not, it would consume a lot of resources, and you also see this only enabled for this work area. Okay, now I do. I already said that nothing was coming out of me. Let's see. Now maybe I have to close and open. Maybe now this is handling it, puts here now. When this down here is finished, indexing and such, start giving me information. No, well, I don't know. Now, yes. Here he starts telling me things. Okay. Well, that's it. So this code here, since we have minted 1,000, what it is going to do is that it is going to directly return it to me. What you have to do is give us back 1,000 expendables with this kind of information. Not what we're telling you here, that with 18 zeros with this kind of metadata information. Where aren't you going to keep it? Well, once again, a type of data type that is exclusive to script, which is called bucket, which is the counterpart of bowl. But if this was a permanent container, this is a temporary container that is not going to serve simply to move fungible or non-fungible tokens within, for example, in this case, a function of a method. Within that of the same execution, the moment we finish that execution, this bucket should be erased, stay dead, throw himself at another, but he shouldn't be alive. In fact, it will give us an error if we have left something inside a bucket. If we haven't deleted the bucket, that is, it's going to tell us, hey, be careful what this is not, and it's not going to let us even compile it. Will this allow us? Well, or it's one of the pretty things he has. Whatever happens to you, it prevents you from making those types of mistakes, leaving things lying around or empty. Or YY when we are doing programming, which has to do with carrying data, in this case, valuable data, such as an asset from one site to another, etc., etc. What we don't want is for assets to be left lying around without knowing where they are going or where they are at any given moment. Then we save it inside a temporary container to which we attach it. It is a variable that we have assigned to it, which is of type bucket. So this variable, this my bucket, is going to save the 1000 tokens that we are going to create here. And then what we do, if you realize it, to pass it to the already permanent structure, is that within here of self-self, it will always refer to us. To the structure inside this, we say that the vault is going, we are going to put my bucket, the 1000, of course, to convert a bucket to a bolt. If you remember this bolt guy, they have already created different systems or methods for us. And one of them is this. This drive is worth it, that it is point to point. That is, with bucket, that is it, comes from a bucket. I am going to create a trunk that comes from a bucket. What bucket? My bucket, which is the one we've put here. We may have put coins, that's it. That's what those are. They are arbitrary, okay? And we would finally be saving what we have said. We instantiate, we globalize, and this should give us a direction. It's worth a component. A component it also contains. One method, in this case a method. So much for a question, Guillermo.
No, I'm not following you.
If you have any questions or anything, you tell me. Of course, what's wrong? It's just not good for this, right? Well, imagine that here suddenly I said, look, we are going to do something. We are going to this component, we are going to be able to take. And I'm going to fuck myself. If I've done well, I'm going to fuck 500. If I did this and compiled it, in theory, it should give me an error because it would have left 111 buckets completely empty. You know what? Because here I would just be taking 500 coins out of this bucket. Okay, and I would be passing them here, and we would have another 1000 loose coins left inside here. Okay, so let's take it and let's look good. We are not going to say in resim, whenever I start with resim, I do a resim reset so that I know that there is nothing previous that is hindering me, or reset completely cleans. It completely cleans the console, the radishing Jane in Simulator Veil. And that way we know that nothing is bothering us or hindering us. I do a resign new account. If you do a reset, you have to create a new account. Okay, we saw that the other day. And here, if you realize it, it creates an account number for us, gives us the public key, the private key, and he also gives us the owner badge. Okay, it's a badge that is nothing more than, if you realize, it's 1NFT with identifier 1. This is exclusive to. In principle, it is exclusive for each account. I'm actually telling you. The accounts within Radix are nothing more than blueprints. And when I have said a resign new account, what it has done has been to instantiate a new account within the account type blueprint. And so this, what it has given me back has been, it gives me back a public key, a private key, and a resource. He's giving me a resource back. This resource would then allow us, if I give it to you, I would allow you to manage my account without having my public and private key, because it is a key for my resource. Do you understand, William? Until the accounts, everyone was thinking in their mind, in the traditional crypto, public and private, no point Radix goes further. Thanks to all this that we saw, you remember the first day or the second that we were seeing that it is a system designed by layers. Okay, what he's managed to do is move, and we've been watching. It is transferring a lot of the logic that in other networks is within the consensus layer. It has moved it to an intermediate application layer, and within the application layer, which is the reader's engine, it has created new types of layers, creating abstraction systems such as the account. The account that is something so linked in some networks to a public-private key, and is such a limited Radix primitive. That primitive opens him up, moves him from one place to another, giving him even more security, but also more possibilities. And then it doesn't turn it into a blueprint that we can instantiate. Finally, in the Radix, everyone is all blueprints. In this case, it is a blueprint. And that allows me that my only way of interacting with an account is not a public and private key, but it can also be 111 badge, with which this and this badge, you imagine that I pass it to a component, and that component is the one that manages the account, for example. The possibilities that open up are endless. That's why in no time, we are going to have the power in Radix, the recovery of accounts in a decentralized way through multi-factor systems. Because in the end, we are going to create things like this. Imagine that you tell your account that you give it create 3 recovery badges. You recover it. But you give it to trusted third parties so that they can recover you at a given moment, the account if you want. Okay, this is like a small parenthesis tip. Okay, but what does it do to explain? Because why does it appear here a badge? It's worth a resource. In this case, 1 NFT within an account because, well, that's resign new account, it's okay, and a resign publish. Control. It says package, hello is specific twice in the look file. Oh, did something happen to you here at the look file? Okay. He's complaining. Wait for control. Nyen, not control B. Sorry, this one is complaining that in the East it is called hello. Okay? Here you have to change it. I forgot this example that we have changed here. This is the module here. I think I have to put it here as hello. See, that's what you didn't like. No, I don't know why he tells me this hello thing. Package says hello, and if I'm from twice in look file. Cargo. Oh, wait. Yeah, I'm here, aren't I? Those are the boxes from the live show, right? This is the tool child. This component's the fault. Here in the call. No. This sometimes deleting this seems to see, I screwed up, Tom. Oysters. Wait for this. This is the one I wanted to delete. This one to see sometimes loading the look, you know, that one works. It's as if an attempt had been made to compile, you know, and that's why you see that the position, the look is no longer there. That's it. This is this. That's why he puts the padlock, because that's when he tries to compile something and he already had it compiled with the hello, and now it is. I had completely changed all this for him here and he was going crazy. So we've erased this one and that's it. Well, let's wait there. We're waiting for him to give us a mistake as well. Well, while you do it, it's fine because it's going to take a minute. I think we are going to explain the good and here from here the methods. Okay? We have simply been looking at the function to instantiate it. It is good to create the component, and from here it creates the component, not just with what we tell it in the instructions we have given it here. It's okay with the data or whatever assets we want to save here, but it's also going to save it, or it's going to instantiate it with all the methods we have here. A method is nothing more than a function that receives by default the mood self. Well, the I is not the alien mood self. What is this about the mode self? Well, here's what we know, right? Public function could, if I don't know if we couldn't create functions, so they were not public, okay, they would be functions that would only have access within the component itself, not from outside when I wanted to be able to call it from outside. That is from, for example, from a transaction to a wallet, since I have to declare them public, the mood self function is that I have access to the self. What is the self? We saw the structure before. This is myself. It is worth the structure or other methods that it has. It is worth, that is, you have access to yourself. In fact, if you realize here, to access Sampribad is not called vault to access vault. We are going to change it there to access vault. Okay. First, he had to call the self. Self. Vault, what is this mutable? So we are telling him that we are bringing and what his thing is. And this is a pointer. That is, I am not bringing everything. I am bringing the address, the pointer, the place where we will talk later about the whole issue of loans, etc., that it has with the variables. But it's a more complex topic. We'll see. Basically, it will just let you know that when we see this here in front, that we haven't seen it here, you don't have it here. Okay? If you refer to me, well, here now I'm making a lot of mistakes. It is referring to this. Referring to what we have is that it is a method, which is not a function to instantiate. It is a method, and it refers to the entire component in itself. That is, once this method has been instantiated, it knows, or is aware, or we are telling it to be aware of the entire component, which we are not going to be able to do with this instantiated. Once I have already instantiated it, it cannot return to call. I have already instantiated this method. No, because it has no awareness of the component itself. I call him, but he doesn't know what to do. No, he doesn't know anything, you know? This is not this, that's why it's a method. Is this already aware of the entire component? And so that's why I can use it once instantiated, or I can use it from outside. Let's see what errors it is giving me here. It says pro macro creative busing build, and what things it is telling me. I don't know what he tells me. Okay, we continue. Okay, and this. If you noticed, you know, we are telling you it's okay that this function, this method, or rather, is going to give us something back. What will this method give us back? Well, he's going to give us back. We don't know what exactly, but I mean, we do know that an asset is going to return us an asset wrapped inside a bucket, a temporary container. That bucket is going to go to our wallet, and when it reaches our wallet, he drops it and he will die there. Well, this has already given errors. Here it gives the complete example again to do previous error. I don't know what, well, that tells me the sample bound errors come. Well, I have corrected that. Okay, I have corrected it to the sample bound sample bot, and notice what Canon says. I delete add mutable coins as it is not declared adds mutable. $500, see? He's telling me, hey, that you haven't declared it mutable. This is okay. It's giving me an error here already. Well, then it will have to be declared mutable. If I want to reclaim with this, it will be worth it, and we'll see. And let's put publish again. Are we going to republish it? It's okay to see if the errors that I was giving me before are worth mutable, and these others that I think we have already corrected, it's okay for us. It'll take less time now. Once the first one is compiled, it takes less time. We were here, we weren't here. Okay, so what is going to return us, we know is going to bring us an asset wrapped inside this temporary container here. Well, look, he hasn't now, yes, he hasn't compiled it. But this would then give us an error. Surely this here, because this is sure, then it would give us an error later. No, it wouldn't let us do it. That is, the moment we are going to instantiate it, lets us compile it. But at the moment we do. Without instantiation, it is going to give us a sure error. This now. Now we finish this, okay? So here, what is it doing? Well, the first thing he's doing is an info. Of this veil, this is nothing more than a macro that allows us to extract veil. It is like a console log. Come on. For those who know JavaScript, it is a console. Log allows us to extract information per screen when we execute this more character information for the programmer at a given time to know what is happening then. In this case, it tells you my balance is here. In theory, there should be a fact, hello token now given away to token. And now eat. And then here comes the information that is going to be introduced into the brackets, these of the keys. This is what self-vault data, that is, we go to the vault and we use it because this is this amount. This feature that the Radix people are giving us here, which I can tell a vault, for example, to mount calmly, okay? And then he returns the amount to me, adds it to me, and returns the amount he has exactly here, okay? And then what he does here is self-vault. Take one. And you realize that here, if he does, and here he doesn't do it, it means that what this line gives back from this line is giving back to us. What does save return? What does vault return? Well, it returns a backend. Take. Look, you see, take that returns a backend. Do you see it now? Yes. Now it's finally gone. I've already finished compiling everything. It's giving us a bucket back. So I know that when I run this, this has to give me a bucket so we can see that this works. I could make Lele token. Look how they know the token type bucket is equal to vault1. It's okay. As we have the here, this is not returning anything. Absolutely, what I am saving is this one. This what I am taking, I am saving in token. Well, what I return is token, and now yes, this makes me return the bucket with the bucket simply by putting the token instruction. This simply makes me return this here. What we had said here about 500 is worth here to show you how this works. When we are returning things with a method, a function, here, for example, I could do let component, exact let component. Notice that here, he is already inferring this to me when he puts it in gray. This is this. That directs you to install the roast analyzer that he already knows that this is from the east. It is ELF. It is of the global type example that we have. It here is worth the global type example. Do you see? He already knows it. I could actually put it, okay, this is of a global type example, okay. He already knows it. If I didn't put it, I would be inferring it. And the Rastagalizer himself is telling me, he's going to tell me, okay, why am I doing this? Notice that here it tells me, hey, you can't return this because you are already putting it into a component. I already know that I am putting it here. That's why I put it. Now, what are you going to give back? I could return component directly. Notice that I no longer have an error because what I have done is instead what I return it directly. I am saving this line inside a variable, so I can now return it because I have done this here, because what I want is, and here we are going to see a new type of data more, is to create a tuple and a market. A tuple inside is a type of Rust data that is meter. Two or more types of data within one, that is, it is to group two or more different types of data. It's okay for them to go together. And what we do is that we encompass them within parentheses. Okay? So here's 2 in global, this YY bucket, and he's waiting for me here to send him a tuplak. Atom with note that you already know it with coins. And now, yes, now this would work. Why? Because I have passed 500 coins here to the trunk, to the vault, and the other 500 that must be here must be followed here. Now I'm going to return them directly to the wallet that this bucket has instantiated, and with this I would be done. We'd save it and publish it. Here I had already made the publication with this package name. Here he's giving us a different one. Okay, come on. What time do we have? Wow. 39, we are going to finish. If you want to do the quick example of instantiating the code we saw the other day, instantiating this we've done, okay? It would be resignation. We already have the package. That is, the package is already published. When I do publish here, it is as if I were publishing the package on the Radix network. In this case, in the simulator, okay. I would already have the package uploaded to the network. And now what I am going to do is instantiate it, okay. I already have it saved inside the package network. And what I want to do is instantiate it. Then it would be resign. I want to call a function. The name, the package address. The name is an example of the structure of the component. Example, the function I want to call new, and I don't have to do absolutely anything, we execute it. And if you realize, he does a lot of things here, okay? Well, here, this is for a day, quietly. See how this works. We're going to do it, huh? We're going to end up doing it, okay? If we go to the beginning, it says, well, transaction status. This transaction has been fantastic. Here, it gives us a breakdown of all the costs. This is super interesting, especially when we have to debug code, debug contracts to optimize costs. Here we put, for example, the execution cost, the completion cost, if we have sent you some type of tip. The cost of storing this is the most important thing that we will have to evaluate. This here is always worth the storing cost, the execution cost too, but the storing cost is above all worth the royalties if this contract had some type of royalties, okay? And then the number of events that it has produced here, we see if you realize that he has done different events, notice that he is doing 500 events. When they create 500, 10th 500 has been placed somewhere, not 1,000, 10th 500. This is the file, okay, this is the file we've created, etc., etc. Okay, here is a lot of information about how you are doing all the transactions inside Veil, little by little, to be able to have everything ready. Also, if we had some kind of glitch here, we could see where we've had the glitch, and then at the end of the whole, notice that it tells me here that outputs has had 3. It's worth a good one, the unit that is this always puts it. But well, then the tuple, notice that it is reference, and that the component has given me the direction of the component, the tuple that we have put here, that I have said this is basically what it gives us back. It's the address, okay? And then a bucket. And he tells me that bucket represents it here with an internal component of this. This would be inside my wallet. But hey, it's so that we can see here, okay, that the tuple gives us back, okay? And here it tells us that it has made 4 changes. 4 changes it has removed us. On the one hand, it has removed us. So it has made a 500 of 500 theta ta. That has made several changes, okay? And finally, the new entities I've created. On the one hand, what we've seen before, that this is this right here, okay? You see S0F is this, okay, that new component that you've created. We already have instantiate the component. And if you notice a resource, it has created a resource, which is what we have done. Create this resource here, okay? He tells us, look, I have created these 2 different things. A resource, because of course, not just the resource, let's say, although what is inside the component lives on the network. The resource, you know, is within the network. So let's do a resignation show first of the component. What does the component have? If you realize, well, he says it's an example, okay? And he says, look, he says he has a consumable, a resource worth 500 hello touch. This little number here is the address of the resource. If you realize, it is the same one here that ends, because it is the one that we have created, the resource that we have created. If we now do a resignation show the account, we did that completely at the top, didn't we? I didn't keep the account number.
I don't remember taking her out.
No, I didn't keep the account number. They're always the same, you know? The accounts are usually always the same. Red thing shing show, a ver resim show. Let's try this one. It is perfect that whenever the simulator starts, it starts with the same ones. That is, they are not invented again, but rather they are the same. Notice that here we have, this is the account that we left at the beginning, okay? We have to notice that what I told you before, this account also comes from a blueprint. This is the blueprint. Notice that it is called C, T, N, okay? He is telling you here, which is the blueprint name account. Okay, and I have 2 resources. I have the 500 that touch it, which when I instantiated it, my account returned them to me. The account that I have instantiated at that time. Okay, and on the other hand, I have the 1000 Radix that are given to you when you create the account. Okay, so we've seen this work properly. On the one hand, we created the 1000 tokens. We kept 500 for him, and we brought the 500. He returned them to the person who has requested his account at that time. I know that that component is okay. If now to end the play, okay, let's take the component. The component is show this component here, wait for this one here, okay? If I did a resim. Home method is worth what method? The method of this component. You have realized that it is also called a different function method. The method of this component is worth and is called free token. Here again, it does everything we have seen before. The Correro este. And finally, here what it tells us is that there have been 4 changes worth the 5. And that it has taken one of this resource within the component that this internal bolt has. And that this resource, what it has done, has been 1 plus 1 in this which must be this internal bolt from here, which must be the one of my account. If we are going to account, resign show. This account, we will see that we now have 501 hello tokens. Okay, so we've seen that this has worked perfectly as well. Well, to summarize this, we are going to see it little by little. We are now seeing things in broad strokes, how a one works. a component, not a blueprint, a component, etc. Things I would like to make very clear. The most important barrier that I believe is that for many right now, this is valid, including you. William, is it Rust? Yes or no? Okay, if I noticed, I've been making mentions of Rust, but I didn't want to talk about the language itself. Something first and such, because I want you to realize what a Rust. So you can create contracts without knowing Rust. I know that what I'm saying is going to make a lot of people hate me. I was going to say you're going too far. But let's think for a moment. What is a contract? We saw it today. A contract is a place where we store data and assets and where we then have a logic for those contracts and those assets. Okay? No logic. Creating a resource, creating resources within the contract is always exactly the same. There's no difference. The code is repeated over and over again. Okay, it's very easy. So, what changes and where is it? Where do we need Rust? When we want to create complex logic, the more complex we want to create logic, the more we will need to know about the rest. But what complex logic we need many times. What does a network actually do is store information. Don't you? We can actually save information that we are going to need normally within the contract. Information that we're not normally going to need outside the contract, outside the network. Is that never worth it to begin with? What is actually saving information? Or what is it that really works? This is saving assets. And those assets that we are going to do is move them from one place to another. The logic that we are going to implement is simply to move the assets from one place to another. In the end, this is the ball game. He just changes the little ball from one place to another, you know? And then, if you've noticed, we have things as simple as take amount. We haven't seen the put, but we could have seen the put, you know? That is, move it. The functions, we haven't seen it today. See you here the next day. Here we can look. But it's giving, we can put touch and go from touch to this function, to then be able to execute them in some way and move them or save them inside, you know, and then inputs and outputs. Forgive in and out of what? Of assets that we are going to move with some type of logic. So in the end, you will realize that the logic when you move assets cannot be so extremely complicated. And when they get complicated, I use Super Maven, for example, which I can tell you how to create a loop in Rust. I already have the logic there. That's it. If you know how to program, I mean, if you understand the logic of programming, a loop, an if, an IE, a conditional, a Boolean, i.e., the logic, what you are going to do in the IE programming, you just need to know how it's done in Rust. And the logic that you're going to use here within the DE of the component is simple logic. Think about it first. In normal logic, you write it and then try to see how that would be done in Rust and support yourself an artificial intelligence that does that very well. You know what I want to tell you? You know what where is Argentina? So why is he? People say it's so hard to create that is right in Rust. Well, first, because Rust is difficult when we are making other types of software, okay? No, this other type of software, this is software that only moves assets from one side to another, starting from there. Okay, or if he keeps some kind of information, safe or read, that's it. Sorry, okay. That on the one hand, on the other hand, because there is one thing in Rust, which is the topic that we will abound much more another day. Maybe we'll just do that for a day, which is the issue of loans. Okay, I mean, there are people who get stuck because they're used to handling variables in any way. And in a RAS, you can't handle variables in any way. For example, we have seen this before here. Many people are already shocked that I have a variable to be able to do things with them. I have to tell it to be mutable or not to be mutable, for example, okay? Or for example, imagine that I now use coins here, and then I want to use it. Imagine that here I use coins for one thing, and then I want to use it. Then I would have to have loaned him the variable or created the variable. That is, there are a series of things. The issue of borrowing that the Americans say, not on the issue of variables, which does complicate Rust a little, but that at the moment when we more or less understand what it is like, it's searching. And also that the compiler then gives you tells you in many cases, notice that he told me, hey, put it down. There you realize that he told me. That is, he realizes that if something has good Rust, is the compiler, it is the best thing that exists in the world, and not said by me, I have told it by all the programmers in the world. When they see the Rust compiler, you say, if the raster compiler says many things, friend, it is that the raster compiler designed to help your life. And among other things, if something does very well in helping you, it is precisely that, in borrowing, in using, because that is what he is always looking for. Because if something, why Rust? It is faster than other languages by far, and is used to create very fast, good, or very high performance systems. Why? Because it handles memory fantastically. In the end, variables consume memory. So Rust, it doesn't have a garbage collector, which is what it says. Other slower languages have a system, a garbage collector, that what it does is look for variables. It doesn't have it because it forces us to program the variables correctly. When you use it, you use it. When you don't, you kill it and shut it down, you know? So it never remains. It does not prevent you due to protocol. It prevents you from making bad memory use practices. And that's why, that's the most complicated thing about Rust. The compiler is well thought out to help you as much as possible to overcome this complication. I say all this so that people who have seen there in this one will say, oysters, this is very complicated. This as I don't know what, you'll see that he trusts me. It's not that difficult one. And then we have tools. That is many tools. How do I know all this? First, I'm going to repeat them again in case someone is not like that. We have the entire guide. Look, here is what we have done today. Okay? This is what we have done today. He explains it to us. Look at the account. Everything we have seeing today, you can see the Rekim publish, explaining it to you little by little here, step by step. Okay, then the next one, the project is worth everything we have seen here. What if the simple trunk? What if I don't know what if everything is explaining to you step by step is okay? And today we will have arrived more or less here in the third, okay, where we have put something else in it. We have modified something, that is, we have personalized it. The next day, we are going to start with the mythical gumball machine, okay? But notice that for that he is telling me to clone it, but we are going to go to these official examples, which is the other largest source of well information within GitHub Radio's DLT official. Examples, we have, for example, the Steepy and Step, which is what we are seeing now. We have all the examples here, but in official examples, we also have the Getting Starter, for example. Well, not this one, wait for it. For example, this one here, for example, prof. We will see it later, okay? But the prof is worth the test. Look at all the code you have. I think they have put it simply to explain to you how the tests work for all possible options. Okay, this code is useless. It serves as a demonstration of how to use it. Okay, so they have a lot of this code that you can read and you can see. To see how things work, design patterns, when we look at, for example, the proxy pattern, okay, look, Oracle 1, for example code of what an oracle would be worth, an oracle. That is, there is a lot of code that we are going to go reading. Little by little, we are going to see. And where there are many times, well, you search, you look for things like, hey, how this is done. Hey, how the other thing is done. You search and read the code. Okay, besides him, I don't want to go through mentioning him because you also learn a lot. Docs, he's not in Docs. Let's see, in the Pepper Hub, learn here the what's the one, okay? I think we no longer enter this, no. For example, resources, I don't know where it was. I see it explains to you, PAM non-fungible. Fungible, the resort builder that we have seen there. We have seen this, which is the new fungible. Another day, we are going to see the non-fungible to make the NFTs. He explains it to you step by step, all pi. There are a lot of lessons, each with its agenda, etc. That is to say, no, we are not alone. That is, there is a lot of information. In order to be able to learn how to do it, okay, and more information than what we will see, and what we will show another place where I learn a lot. Within the Radix repository, it is in the challenge. When Radix challenges all the code that is written, or in those challenges, all the participants remain, the code remains there. For example, I want to do nothing. Come on, nothing or Lendi. Look how many there are. I don't know if I know. Look, 246, 911112, 213, different data, each with its example. Enter one of them. I write the SRC. Look and look. Look inside all those who have crazy member policies. I don't know how good I'm going to enter into this. Look, he explains everything step by step here. Bang, bang, and then look at how this one has worked, okay? And here you see how he has done it, how he has created it, and so on and so on. That is, it is given, for example, if by things, if by stories, so that we can know how it is done, okay? Then it's not that difficult, okay? It's not that difficult, right? I mean, no, I'm not going to say it's easy. But it's not that hard, okay? And little by little, like we're going to do it over many weeks, right? William, little by little. One is seeing and becoming more and more familiar with script and with the different syntaxes of the language itself, programming, and with Rust. And you can write script and not be a great expert in Rust, simply for what you need, and that's good.
Excellent. Well, very well. This has interested me, a lot of information. Are we starting to see some code like this, Father? And so we continue with the following lessons. If you have doubts, questions, you can ask through the live chat with comments for the following videos. Thank you very much, Andres. We left you so that you can rest your throat, also because you are Malon just like me. Then stop so you can rest your throat a little. Thank you very much. Thanks to everyone who stayed to watch this and those who are going to watch it later in Spanish or English. Be very well and see you in the one that follows by.